So we have only looked at whether, you're saving money or spending money or accumulating credit card debt or decay, but not anything that's interrupted. So when you take out a loan for something, you have, you're in debt however much money it is. So let's say $10,000. But that interest doesn't just accumulate over time. You're also paying it off, right? You're making payments. So you're not going to get $311,000 in interest because you've been paying on it. So this formula is going to show, given a loan amount and the payments, can we manipulate this formula a little bit? Or given a loan, how much is our payment? Or given a payment, how much loan can we get? So a lot of times what people think about is like going car shopping or going house shopping. When you're buying either of those things, you have to think about what you can afford. So you look at your finances and you say, okay, I can afford a car payment of $350. Well, what does that translate to in terms of a loan, right? Does that make sense to you? Like, that is an actual thing. So this formula is sort of set up to help us look at that. My real goal today is for you to see that when you're given a formula, it's not good looking, right? Do you see this formula as a nightmare? And sometimes there's extra things written there in the formula that they give you when they give you some information that you're not paying attention to, and it's making you get things wrong. So being careful about the details. So car loans and mortgages, they're called annuities because you are paying monthly. So in order to account for payments, we need this formula. The present value of an annuity, A of P, so that's like your loan. A of P is like the loan amount. So are you buying a $200,000 house? Are you buying a $25,000 car? How much is your loan? Consisting of equal payments of R dollars at an interest rate per time period. So what letter do you not see in here that we typically see? Okay, usually we have a present value, okay. What else? N is in the exponent. Yeah, little r. What? But they're using I instead, right? But be careful because it says interest rate per time period. Well, the interest rate is usually R. So interest rate per time period. And in all of these cases, when we're talking about an annuity, we're talking about monthly payments. So what's N? 12. So N is 12 in general. Okay. So above here, it gives you a scenario about Emily. Emily's buying a car. Emily wants to buy a car for $12,000, but does not have enough money to pay for it all at once. She goes to the bank to get a loan instead. Okay, so we know that her loan is going to be $12,000. So A is going to be $12,000. This asks us how much will each of Emily's monthly payments be over the 4-year loan at 2.87% interest. So what information have we gotten from there? Okay, so 12,000 we have. What else? The rate. So R is 0.0287. What else? Time. T is 4. And they do tell us monthly payments, so N is 12. What are we solving for? R, equal payments, right? Payments of R dollars. So we're solving for R. A is 12,000. R times. Now, I want to be careful because I was watching some people do some things that were bad earlier today. So don't put anything down. Everybody put your pencil down for a second so I can show you what's going to happen, and then we'll fix it so something good happens. So put your writing utensil down. We're going to plug in here 1 minus 1 plus. I is r over n, so 0.0287 over 12 raised to the 12 times negative 12 times 4 all over 0.0287 over 12. Close the parentheses here. Is that a hot mess? It's an absolute disaster, right? And nobody likes that. So my suggestion to you is this. Don't do that. Go off to the side, and instead of writing I in there like this, figure out what I is. It's the rate divided by 12 months. And store this in your calculator. Okay, so go to your calculator. I'm going to remind you how to store. Get a fraction. It might be charging. 0.0287 divided by 12. You press Control and the key that says var above the 9, and you use the keypad letter I. That's a whacked out decimal, true? Nobody likes that one. Nobody wants to write that. Nobody wants to round that. We want to store it so we can use it in a second. So now in my formula, I can call that I. I've stored it in my calculator. I can call it I. So 1 plus negative 12 times 4 and so I is stored on your calculator. Is that okay? So we want to solve for R. Well, how do I get R by itself? Divide by that atrociously large set of parentheses fraction. Now, what I want to point out to you is, do you guys see that negative 12 times 4 is only on this set of parentheses? It's not on the complete big parenthesis. I was watching some people mess that up earlier, just because you have so much to write and it's all squished in. So I would draw those big parentheses last, maybe. All right, so we're going to divide that over. So 12,000 divided by 1 minus 1 plus I to the negative 48 over I, close those parentheses. Again, just the 1 plus I has that exponent of negative 48. So now you can use your calculator. Type it in exactly as you see it so you don't make a silly mistake. And because you stored I, you should be all right. You can just type it in. If it comes up bold, that means it knows what you're talking about. If it doesn't come up bold, that means you didn't store it properly. So, how much are Emily's payments? And 92 cents? So $264.92. Okay. So, all is good. Now if you go down here, or on the next page, it says, Emily realizes that that's too much. So she says, wait a minute. I can only afford to pay $200 a month. And this will happen to you at some point in your life. You're like, okay, well, I want to do this. Well, this is how much I can afford, so maybe not. So everything's remaining the same. Her interest rate is the same. The time period is still the same. So she's going to have to buy a car that's of lesser value, right? She can't get a $12,000 car. So we don't know what her amount is. We see that her payment is $200 per month, so that's R, which means that we're solving then for how much the loan is, for A. So A equals 200, 1 minus 1 plus I, because we still have it stored, to the negative 48 over I, close the parentheses after the negative 48. So, how much of a loan can she afford? Type that shenanigans in. How much? 9,000. $59. Okay, $9,059. So probably around $9,000. $9,059. What's the change on there? Okay. Are you okay? Yes? Nate? Are you good? Okay. There's a typo in this formula. Can you see it? Yeah. And that's inside the parentheses. So we're going to ignore Laura. We're going to talk about Jeff. Jeff wants to buy a new BMW for $60,000, $60,600. He has a $3,000 down payment and will finance it for 48 months at a rate of 4.14. 48 months is 12 years, or 12, good job, 12 times 4. Yes, we just saw that same example. So 48 months is n times t. Sometimes you're given them together, and sometimes you're given them separated. So I want to be consistent with the formula that we use. Does that make sense? Other one? Okay. At a rate of 4.14. So R is 0.0414. So over here, I'm going to write down what I is. And then I'm going to store it. I is 0.0414 divided by, we're doing a monthly situation each month, so divided by 12. Store that in your calculator. So easiest way is to doc B, clear it out. And those of you that haven't figured out that I use the scratch pad only, welcome to the world here. Store it for I. Now that one worked out kind of nice, right? 0.00345. The last one was an atrocious mess. It just depends on the scenario. So sometimes it'll be okay, sometimes it won't be. I just prefer to store. Okay. So how much is Jeff's loan for? Mm-hmm. What did you just do to get that? Yeah. The car costs this much. He pays them this much before he leaves. His loan is for $57,600. We want to find his payment. And it's to the negative 48 over I. Make sure you close the parentheses after the negative 48. So what's the only algebra step you have to do? Yeah, divide by that. So show that you're dividing. And see how much he's going to pay. So he's going to pay $1,304. And what was the change on there? Okay. That's a lot of money for a car. I'm not going to lie. So Jeff realizes, you know what? That's a lot. So that was financing for 4 years. He's going to finance for 5 years now. But what does it do to his interest rate? Oh, sorry. What does that do to his interest rate? Goes up slightly. You see that? That's a dirty trick. So this time, I is going to be 0.0417 divided by 12. And our exponent NT is going to be 60 months. Or 5 years times 12 months makes the 60, if you wanted to break them up. So, same deal. The price of the car doesn't change. We're still looking for his payment. 1 minus 1 plus I to the negative 60 this time over I, then close the parentheses. So the first thing you need to do is store the value for I, because that's a new one that we have. So I like to clear. That way there's nothing in there to mess me up. And you know you're going to divide it over. So 57,600 divided by all of the craziness. So 57,600 divided by all of the stuff. 1 minus 1 plus I to the negative 60 over I equals R. How much does it change his payment? It should decrease. Decreases to what? Go ahead. 1,065 and 22 cents. So, does that help? I do have it. Oh, your brain's decided that it was different than it was? Okay. So, he's going to pay for less each month for a longer time, which means he's going to accumulate more interest, right? And he's financing at a slightly higher interest rate. So it says down there, what's the difference in the interest? I'm not going to worry about that. If you were Jeff's friend, what would you tell him to do? I tell him to pick a different car to buy, first of all. Jeff, get yourself together, okay? And then I would say, do what you can, do what you want to do, man, but a lot of times what people do is they pay extra on their loan. They finance, and then every month you just pay extra, and it makes it go down faster. Okay, we talked yesterday, we went over the two from the homework yesterday, right? Those ones on there, okay. So, I want you to go to page 52. I want you to see what should look like this, yes? Gabrielle needs to get a loan for her master's degree. She needs to finance $24,000 over 15 years at a rate of 6.02%. Right now, I want you to find the monthly payment that Gabrielle will make if she finances for 15 years. Okay, go ahead and do that. Number one. I want to do number two with you, though. So, you stored for I. What did you store for I? 0.0602 divided by, because it says monthly, 12. You store it. The current loan is $24,000 equals R 1 minus 1 plus I, which I stored, to the negative 15 years times 12 months is what? 180? Negative 180 over I, then close the parentheses. So what do you get as R? 202.79? Okay. Now, number 2. Determine the number of payments. So what are we solving for? N times T. So number of payments, N times T. So I'm going to call that X, right? Because things are going to get wild otherwise. Gabrielle will make, if she finances for 15 years, but pays an extra $150 a month. Extra. So right now, so this is what I was talking about. People pay extra on their loan to make it go down faster. So her loan is still $24,000. But how much is she paying each month if she's going to pay an extra? $352.79. Okay. So we're solving for what's in the exponent, right? Are you ready? Because do you see how it's ugly? This doesn't look like a fun time, does it? So what should we always do first? Get the weird thing alone. Right now, the X is inside a layer of parentheses, which is also weird, right? So what's your first move? Divide by the 352.79. So 24,000 divided by $352.79 is equal to 1 minus 1 plus I with the negative X divided by I. You see what we want to get alone. We want to get this thing alone. What should I do next to get that alone? Times by I, okay. So 24,000 times I divided by 352.79. When I multiply by I on this side, they go away. Equals 1 minus 1 plus I to the negative X. Right? You're still got like 3 moves, maybe 4. Is the weird thing alone yet? No. So what should I do next? Subtract 1. This is a positive 1, true? So I got to move that over to the other side. So 24,000 times my interest divided by my payment minus 1 is equal to negative 1 plus I to the negative X. Are you having fun yet? No. Now what? You cannot distribute the negative. That's like having a negative 1 out front. So what do we always do when we have a number out front? Divide by it. So I'm going to change this to a positive, which means this is a negative and this is a positive. Because writing another step right now would be atrocious. Now what can we do? Did we get the weird thing alone? Yeah, now what? Change the form, undo the weird thing. Okay. Log. What's the base? 1 plus I. What goes inside the log? That whole side equals negative X. Good grief. What's your last move? Divide by a negative. So I'm going to make that a positive. I'm going to toss a negative out there. So, well, that's good looking. No, it's not. Okay. So, calculator. first of all, we have to make sure I is stored. 0.0602 divided by 12, stored for I. Negative log 1 plus I. Negative 24,000 I over, what is it, 352? Was 0.79. And then is it a plus 1? Is that right? Yeah. 83.42 payments. So how many payments will she have to make? 84 payments. So 83.4, she'll have 84 payments. Is it?
Yeah.
I thought, yeah. I'm thinking 72 is 6. Okay. Take a deep breath. These next two questions, an element has a half-life of 80 days. What formula do you need? What does that look like? A equals if you don't know what goes next, I'm going to lose my mind, right? A equals P 1/2. Now here's the weird part, right? What's the exponent? T over H, where H is the every. So every 10 days, every 80 years, every whatever it is. Yes? Okay. You should be all right with those. Now, if you don't have a calculator at home, I'm going to give you some time here at the end of class. But if you don't have a calculator at home, see how I did all the things in the last one? And the last move is just typing it in, right? That last, get everything. Get T by itself, whatever it is that you're doing. And then that should be good. We're using an online calculator. All right, so now we have a bacteria culture that is found to double in number every 10 hours. What's this? Perfect in every way. This is the, and now I'm using air quotes, half-life formula, except it's not a half-life, it's a double life, right? So A equals P 2 to the T over H. H is the time it takes it to double. So you want to make sure you have that H there. And then the last two, the population of the United States was about 227 million in 1980 and grew at a rate of 10% compounded continuously. What formula is this? The E one, the PERT, continuous dandruff coverage or relief, I don't know what to call it. Continuous, compounded continuous is A equals P E to the RT. Because everything is in millions here, you don't need all the zeros. You can use 227, 325. Is everybody okay with that?
Yeah.
When you start using all the zeros, gross, yeah? So you've got about 12 minutes to work on those 6 questions. Have your mark and set, go.